Okay, pause the video and write all this down. Okay, so now we're moving on to series that have possibly, uh, negative terms. Okay, I'm going to say this a lot, but I'll say it right now. For the comparison tests, comparison test, limit comparison test, those only work if the series has strictly positive terms. So if there are any negative terms, we need something else. So, and those tools will be developed in 11.5 and 11.6. Yeah. Okay, so first tool, alternating series test. So you can see this series going back and forth from negative to positive. Okay, that's what we mean by alternating series. Okay, here's the kind of general form down here. If the series happens to be -1 to the n plus 1, bn, that's okay too. This test still works. So this bn here is called the, non-alternating part. So 3 things to check. Okay, bn, the non-alternating part, has to be, positive for all n. Bn has to be decreasing, or you could say not increasing. And finally, the limit of bn has to be 0. Okay, so this theorem says that in that case, the alternating series is convergent. And maybe I can do a proof later on, but for now, let's do an example. Let's do the one we talked about above. So the harmonic series, except alternating. So in this case, Bn is 1 over n. So 1. Bn is 1 over n, and that's obviously bigger than 0. Okay, check. 2, is it decreasing? Well, is this thing less than or equal to this thing? Well, yeah, right, because 1 over n plus 1 is less than or equal to 1 over n. Since if you cross multiply here, you get n is less than or equal to n plus 1. Actually, strictly less, right? Three. The limit of bn has to be 0. And we had a limit 1 over n, which of course is 0. All right, so we've checked that 1, 2, 3 are satisfied. Let's conclude by saying, therefore, summation -1 over n, -1 to the n over n is convergent by alternating series test. Okay, so you always have to tell me which test you're using. Okay, another example. A little bit more complicated. How about -1 to the n plus 1, n over n squared plus 1. So as I said earlier, I have a n plus 1 here, but it doesn't matter. If I had n plus 2 or 3, it doesn't matter. It doesn't affect the alternating series test. 1. Bn is the non-alternating part, so I just drop the alternating factor. And this is obviously positive. No problem. 2. Decreasing. Is that true? Well, yeah, I think so, but let's do a little demonstration here. See in blue. So what do I get? What is B n plus 1. Well, what you do is you plug in n plus 1 instead of n in this expression. On the right, we still have bn. So here's my question mark. Is this true? So why don't I cross multiply? Okay, everything's positive, so you can cross multiply without fear of disaster. And what do I get here? I get n cubed plus n squared plus n plus 1. And here I'm going to get n cubed plus 2n squared plus 2n, right? I believe. Then I can drop my n cubes. And I'll move my n squared term over there. I'll move my n term over there. So 1, let's go lower here. 1 less than or equal to n squared plus n. Yes, that's obviously true. Okay, n is a positive integer. Okay, so logically, my demonstration says, okay, this is obviously true, so this is true, so this is true, so this is true. Okay, so my bn is decreasing. 3 is limit of bn equals 0. Well, we have a limit of n over n squared plus 1. You can just drop that 1, since it doesn't matter when n is large. You get limit 1 over n, which is 0. Yes. All right, there we go. Concluding statement. So the original series is convergent by A, S. If you don't feel like writing this thing again, you can just say the original series. Sometimes I write that, but so the original series is convergent by alternating series test.